T. Clark here, and this video is going to go over the unit circle, how to generate the unit circle quickly with a couple tricks, what it's used for, how you can use the unit circle to help you solve some calculations. And honestly, the unit circle is something that I recommend you have accessible, or you write it real quick on the beginning of a test. That way you can solve these trig problems. I have a link to the Desmos graph that I made that I used to make these slides. But first off, here is unit circle with a little bit of the assistance down here. Sine of the angle is the y value, cosine of the angle is the x value, tangent of the angle is the y over x. We'll go over that later. And there's a lot of numbers here. There's a ton of numbers here. But if you follow my patterns, you'll be able to write this out within a minute, maybe 2 minutes. So take the time to write this on an exam. That's what I did on my SAT, my SAT 2s. Even when I became a math teacher, I had to take the California C-set exam to prove that I knew my math. And I took all 3 exams at the same time and I passed them. But the first thing I did on my exams was write out and generate on a scratch paper the unit circle. This helped me with the trig problems. So here's another version of the same thing. But again, there's a lot of stuff. There's over 60 numbers here. It's way too much to look at and think about to begin with. So overview. First thing, you have to start with the circle, obviously. So here's a circle. And then we want to put that onto a Cartesian plane or a coordinate plane. Oh, this should be capital for Descartes. But yeah, so you want to make this in a Cartesian plane. So x-axis, y-axis. Excuse me. And then it's a unit circle because the radius is 1. So the center of the plane is at 0, 0, and it goes out to 1. On the x-axis, it goes up to 1, goes to -1, and it goes down to -1 as well. So the radius of this circle is 1. We'll use that later on, and it's 1 unit. So that's why it's a unit circle. So there are only 5 things you need to know or memorize when you're making this unit circle. 45, pi over 4, 30, pi over 6, and 0, 1, 2, 3, 4. We'll go through each one at a time. So the first number is 45. So you want to have the pattern of 45, and this is for degrees, right? We have degrees or radians. So 45 will represent the degree number, and you just have the pattern 0, 45, 90. So you add 45, add 45, add 45, add 45, add 45, add 45. So as long as you can do some simple math, some simple addition, you're good to go. So like I said, the first number is 45, and we want to draw the angle lines. So just halfway between the x and y axis, we draw a line, just the y equals x and y equals -x lines. And then we're going to label starting at 0. Obviously, we start here. We're going to go counterclockwise, adding 45. So we're going to add 45, add 45, add 45, add 45, whoop, did I click? Add 45, add 45, add 45, add 45, add 45. And you get to 360 and you're done. You could keep going if you wanted to, but we were just doing one full rotation. So 0 to 360 by 45, and those are our angles. Okay, then the next number is pi over 4, and pi over 4, well, the pattern is going to be 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 5 over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So I say it, it sounds kind of funny when I say it and all blah blah blah, but we're going to use the same lines as we have already. So we start at 0, and this is for the radians, and pi over 4. So again, 0 pi over 4 is just 0. And then we go 1 pi over 4, and then we simplify, which is pi over 4. Then we get 2 pi over 4, and then we still have to reduce the fractions. So 2 pi over 4, if we reduce, is going to be pi over 2, and that's what we get. 3 pi over 4, 4 pi over 4 reduced to pi, 1 pi, 5 pi over 4, 6 pi over 4 reduced to 3 pi over 2, 7 pi over 4, and then 8 pi over 4 is 2 pi. And if you should know that 2 pi is 1 full rotation, equivalent to 360, and there is our pi over 4 radians for this circle so far. Okay, the third number is going to be 30, so we're going by 30 now. So 0, 30, 60, 90, 120, plus 30, plus 30, plus 30, plus 30, plus 30, plus 30, plus 30. So draw the blue lines now, not halfway between the 45 and the 0, but a little bit closer to the 45, and the same thing with 60, a little bit closer to 45. I took off the 45. You don't erase the 45 or the pi over 4. Those will still be there, but for the demonstration purposes, I just got rid of them because there are a lot of numbers, and we're just going to focus on the blue lines now. So again, draw the 30 and the 60 lines, and then over here as well, symmetrical. These lines, on your paper, it doesn't have to be perfect, but again, they're a little bit closer to the 45 than to the 1 and 0. So again, like I talked about, the other numbers are hidden for clarity for the 30 demonstration. So start at 0, add 30, add 30. 60 plus 30 is 90, plus 30 is 120, plus 30 is 150, 180. So again, you already had 180 down, you already had 90 down. You don't need to write those again, but it's just confirming that the pattern gets the same number sometimes when they intersect, when they get the common cardinal points and cardinal lines, I should say. So 210, 240, 270, 300, 330, and 360. So adding 30 all the way around, we got the angles for the blue lines. So that's the second number. So we got 30, and now we want the corresponding radian, which is pi over 6. So just like with pi over 4, we have 0 pi over 6, 1 pi over 6, 2, 3, 4, 5, 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Okay, let's do it in green now. So 0 pi over 6 is 0. Pi over 6 is just 1 pi over 6 is just pi over 6. And then 2 pi over 6 we reduce, pi over 3. 3 pi over 6 reduced, we get pi over 2 again. So again, we don't need to write it out. So instead of saying 2 pi over 4, we're saying 3 pi over 6, which they both reduce to pi over 2. And then 4 pi over 6 divided by 2, we get 2 pi over 3. 5 pi over 6, 6 pi over 6 reduces to just pi, we already had. 7 pi over 6, 8 pi over 6 divided by 2, we get 4 pi over 3. 9 pi over 6, we divide by 3, we get 3 pi over 2. 10 pi over 6, 11 pi over 6, and 12 pi over 6 we reduce to 2 pi again. So again, we just had 30 and pi over 6, and then doing the pattern and reducing fractions, reducing fractions as we go, we get the radians. So now we have all the angles and we have all the radians. And again, we just use these numbers right here. I didn't have to think about any other numbers. And this is honestly how I do it. Whenever I make a unit circle, I just use these 4 numbers and then plus the next pattern to get the points. But for now, the angles are all done. The radians are all done. So the next thing is the 5th number, which is the pattern 0, 1, 2, 3, 4 over 2. And it's not just 0, 1, 2, 3, 4, it's the square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. So here are my numbers that I actually want. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. I don't actually write these all out, because if I do the perfect squares and I take the square root of them, I get 0, 1, and 2 here. Excuse me. And I do some simplification. 0 over 2 is 0, 2 over 2 is 1, and I already have 0 and 1. Those are my cardinal points, right? 0, 1, negative 1, 0, 1, 0, and 0, negative something, whatever I had on the 4 main north, south, east, west. So the new points are these 3 in the middle. So 1 over 2, square root of 2 over 2, and square root of 3 over 2. And yes, technically it's square root of 1 over 2, but square root of 1 is just 1. So I don't need that square root of 1 over here. So I already have the zeros and ones, those are already there. So I start up here for x, and I started at 0. And these are the same numbers. I go along the x-axis, and I get my next number for x, which is 1/2. And I put it in my x for the point. Then I put in square root of 2 over 2. Then I put in square root of 3 over 2, and then I get 1. 1's already there, so I don't have to worry about it. So there we go, 0, 1, 2, 3, 4. So that's the pattern. Then I go the same pattern but backwards. 0 for y, 1/2, square root of 2 over 2, square root of 3 over 2, and then 1. And that's it. And those are my numbers. So now what I'm going to do is I have all my the 3 new points actually, because I already had the 1, 0, and 0, 1. But I'm going to use the quadrant rules, right? First, second, third, fourth quadrant had different plus and minus rules. So it's positive up here. I forget what quadrant numbers are, but this is quadrant 1, and I know for sure it's positive, positive. Then we have this quadrant over here is negative and positive. So what you do is just copy the x's over and make them negative, and the y's are exactly the same. The y's stay the same, positive. And then that's my negative x, positive y. And then down here, make them both negative. Just copy them down So x copies down with the negative, 1/2 becomes negative 1/2. Both of these copy down to become both negative, and we have negative, negative from this one right here. So just reflect it down, very symmetrical, but they're all negative down here in this quadrant. And then over here, x is positive, so just copy the x's down, and then the y's become negative. This y became negative, and then that y became negative as well. So we have positive x and negative y over here. And then we're done. That's it, we're done. We got the full circle, we generated it. And again, I recommend practicing this out on just scratch paper. Draw your circle, draw the lines, go 0, 45, 90 all the way around. Do 0, 1 pi over 4, 2 pi over 4, 3 pi over 4 all the way around. Then do the 30s, 30, 30, 30, 30, 30, 30. Then do 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and then do 0, 1, 2, 3, 4. So practice it out, and then you'll be able to just sketch it out on any test you take. Because most math tests, even AP exams, you're allowed to have scratch paper. And that's the first thing I would write on the scratch paper. Okay, so now you have it. You have the unit circle either on a reference sheet, or you're looking at it on your screen, or you have it written out for your test on a scratch paper. How do you use this to solve the problems? So what's the whole point? The whole point is we want to solve sine, cosine, tangent using our SOHCAHTOA. It devolves, or becomes, sine of the angle is the y value, cosine of the angle is the x value, tangent is y over x. So let's look at that. Let's zoom in a bit to that first quadrant that I had. And I'm just going to use this first point right here with a 30 pi over 6 and square root of 3 over 2 and 1/2. Okay, so I'm going to look at that. And then I'm going to draw a right triangle using a straight or a vertical line and a horizontal line. Of course they're straight because they're lines, but it's a horizontal and vertical, and I'm going to keep this this line here. Okay, I'm going to move my angles to the middle, so there's my normal triangle, or there's a normal right triangle, or regular, not normal, but it's a right triangle. Looks like a basic triangle. Yeah, basic, that's the word I'm looking for. Okay, then what I do is I use the hypotenuse is 1. Right, the whole point of the unit circle is that the radius is 1, so that then the hypotenuse, the longest side, is going to be 1. Then this line, but down here, this horizontal line, has the x value of square root of 3 over 2. The y value, the vertical line, is the y value of 1/2. So if you plug those in, you get a nice triangle. Looks like a normal basic triangle. Then you solve SOHCAHTOA. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I label those for this angle, the angle in the middle, not the angle up here, the angle from the origin is 30 degrees. And the opposite is 1/2, adjacent's root 3 over 2, and then the hypotenuse is 1 for all of these. Okay, if I plug them in, sine 30 is opposite 1/2 over 1. Cosine 30 is adjacent, which is root 3 over 2 over 1. And those both, if it's over 1, it just becomes whatever's in the numerator, And then tangent, I do some fancy stuff, so I get, what is opposite over adjacent, excuse me. The 2's cancel out, so I get this 2 and this 2 canceled out, and the numerator becomes 1 over root 3. Then I simplify and get a radical out of the denominator, and it's square root 3 over 3. And there's my sine, cosine, and tangent of 30 values. And then if I did the sine of pi over 6, if I'm working in radians instead of degrees, right, this is technically 30 degrees. If I do sine of pi over 6, it's 1/2. Cosine of pi over 6 is root 3 over 2, and tangent of pi over 6 is root 3 over 3. Okay, going back to just x's and y's instead of having the 1/2 and the 30 or whatever. So the sine of theta is opposite over hypotenuse. Opposite is y. Hypotenuse is 1 still, so 1 is still the only number here because it'll reduce and I just get y. So sine of theta is y. Cosine, again, is adjacent over hypotenuse. Adjacent is whatever the x value is. So the x, and then over 1 for the hypotenuse, which is just the x. There we go. Then tangent of theta is opposite over adjacent. Oh, I need to put opposite over adjacent first. Oh, I fail. So I'll squeeze that in. So it should be opposite over adjacent equals y over x. I think I had that someplace else. I'll just fix it real quick when I'm done with the video, if I remember. So there we go. So sine, cosine, and tangent gives me the y, x, and y over x. So again, why is this useful? That's actually so that's important. So we need this as we use the unit circle. We need these keep in mind sine is y, cosine is x. Tangent is y over x. Okay, so let's actually get a problem and then solve it using these properties. So if the problem says calculate sine of 150, what I do is I go to 150. Go to that line. Go to that spot, and then what's the points? The points, and then I don't care about both the points. I only care about the y, right? Sine is y, so I only care about the 1/2. So sine of 150 is 1/2. Done. Okay, let's do cosine 315. So go to 315. Cosine is x, or there we go, there's 315. And cosine is x, so it's just root 2 over 2. Done. Tangent of 210, so tangent is what? Y over x. Well, first go to that spot, get my values, and like I said, is y over x. So I put y on top, negative 1/2, over negative square root 3 over 2. The negatives cancel, the 2's cancel. So again, I get 1 over square root 3, and then get the radical out of the denominator, and I get radical 3 over 3. Done. Okay, what if it's radians? Same thing. Go to 3 pi over 2, whatever 3 pi over 2 is, and then get the whatever value I want. In this case, sine is y, so it's negative 1. Done. What if I want cosine pi over 3? Go to wherever pi over 3 is, cosine is x, and there we go, 1/2. Done. Okay, what if I want to find the inverse? So the inverse gets me the angle. So inverse means I'm solving for the angle. So I need to find, again, sine is y, so I go to where y is square root of 2 over 2. So I'm going to wherever the matching y value is first, so I get that square root of 2 over 2 for y, and I look up the angle. The angle is going to be 45 or pi over 4, depending on if I'm in degrees or if I'm in radians. So 45 is my answer. But you may have noticed there's actually more than one answer because I have square root of 2 over 2 over here as well. That's a y value. So it could be 135 or 3 pi over 4. So it depends on the interval your problem is solving. It could be both 45 and 135. So it depends on the problem that you have. Because if you remember sinusoidal curves, it repeats and repeats and repeats and repeats. If you're looking at the curve of the normal graph of like y equals sine x. Okay, special right triangles. This is something real fast. Some teachers make you memorize the special right triangles, and then you can find all the stuff based on that. But using a unit circle, we just have the 30, 60, 90 triangle. So if we want cosine 30, sine 30, cosine 30, tangent 30, we just do the sine is y, 1/2, cosine is x, and tangent is y over x. Same thing for 45, 45, 90. If I plug everything in, I get sine 45 is root 2 over 2. Same thing for cosine. And then tangent is, since it's the same x and y, it's just 1. And then to get the 60, I actually use a 60, 30, 90 triangle. I don't look at the other triangle and use the other angle. I just use 60 from the middle. And then I know that the sine is my y, which is longer now. And then cosine is 1/2, and then since there's no radical in the denominator, it's just square root 3 when I do y over x. Okay, I think that's it. Yep. So again, there's a bunch of resources here. I like this graph. This graph's a little bit nicer, but I made the Desmos link. I made this graph in Desmos. There's a link here if you want to look at it, and you can turn stuff on or off as you go. I don't know if that would be useful for you to look at different parts, but that's how I made my slides. Have a good day.